Now, another part of simplifying radicals is we have to be careful when we're adding and subtracting terms if possible. So what I mean by that is combining like terms. So let's review from Algebra 1. Now, combining like terms is mean if you have something like 5x plus 3x, we can combine these two because they both have x. So if they both have like terms, we can combine the numbers. So in this case, 5 plus 3 is 8. But remember, when we do 5x plus 3x, we have to keep the like terms. So 5x plus 3x is 8x. So how this connects to simplified radicals? Well, I'm going to show you how it applies. Our first example, say we have 3 the square root of 8 plus 5 the square root of 18. So still, you'll be asking how would this relate? So we're going to apply the process what we did in the first three examples. So our first one right here, 3, you can break the square root of 8 into 4 times 2 plus 5. Then you can break the square root of 18 into 2 factors, which is 9 times 2. So now I broke it down to 2 factors where one of them is a perfect square and the other one is also a perfect square. So that's good. Next is to separate into 2 factors. 2 square roots. So here, 3 square root of 4 times square root of 2, carry down to plus 5 square root of 9 times square root of 2. Now keep in mind, when we're breaking it down, separating into 2 separate square roots, there's a multiplication sign between the 3 and the square root of 4, between the 5 and square root of 9. So keep that in mind. Now, from this part, again, we can do the square root of 4 and the square root of 9. So I'm going to bring down to 3. The square root of 4 is 2. Can't simplify square root of 2, I'll bring it down. I'll bring down to plus. Bring down to 5. The square root of 9 is 3. Can't simplify that, so I'm just going to bring it down, square root of 2. Now, we're going to multiply the one on its respective side. So 3 times 2 is 6. Square root of 2. Oh, this is supposed to be plus, my mistake. Bring down to plus. Then here, 5 times 3 is 15. Then multiply with the square root of 2, so square root of 2. Now, to review, 3 times 2, that's how we got to 6. And then 5 times 3, that's how we get to 15. Now, let's check. Can we add or subtract like terms? Yes, we can. Because both of these, they have square root of 2. So, how does that work? Now, if we pretend the radicals are like variables. So, for example, if it was 6x plus 15x, it would be 21x. So again, I was just pretending that the radicals were variables. So, since they both have square root of 2, we can actually combine them. So all I have to do is just add the numbers that's in front. So in this case, we're going to add the 6 because it's addition. So 6 plus 15, that's 21. And then we don't have to write it twice, just write it one time, just like how I wrote x one time after I add. So it's going to be 21 square root of 2. So again, they both have square root of 2, so therefore we can combine the numbers in the front. 6 plus 15, which is 21, and then keep the square root of 2. So this is our answer. Alright, so in this second example, we have subtracting radicals. So, just like before, adding, subtracting, we're going to first break it into two factors on each radicals. So, in the square root of 12, from the perfect square numbers, 4 can be a factor of 12. I can't use 9. 16 is too high than 12, so 4 is a perfect factor. So I'm bringing down on 5. Break the 12 into two factors, so 4 times 3. Bring down the minus. Bring down the 4. Then for the second radical, square root of 27 of the perfect squares, can't use 36 too high. 25, nope. 16, nope. But 9, I could use. So I'm going to use 9 times 3 as the factors for 27. So, checking, yep, broken into factors now. I'm going to separate the factors into two radicals on each side. So here is going to be 5 square root of 4 times square root of 3 minus, bring down to 4, square root of 9, and square root of 3. Alright, so separate into two factors on each side. Then here, excuse me, here we can do the square root of 4, and here we can do the square root of 9. So, what I'm going to do is, again, I'm going to bring down to 5, but I'm going to apply the square root. So square root of 4 is 2. Can't do anything to the square root of 3, can't simplify, can't break it down. So I'm going to bring down the square root of 3, bring down the minus, then bring down the 4. I can apply the square root on the 9, which is 3. Can't simplify, can't break it down on the square root of 3, so I'm just going to bring down square root of 3. So, after I finish breaking down, after I finish applying square root, next I'm just going to multiply the numbers where it applies. So here, 5 times 2 times square root of 3 is going to be 10 square root of 3 minus, then over here, 4 times 3 times square root of 3 is 12 square root of 3. Alright, so just like combining like terms, so here 5x plus 3x equals 8x, we're going to combine since both of them have square root of 3. So, basically 10 minus 12, that's going to be negative 2, and then we have the square root of 3. And that's our final answer. So 5 square root of 12 minus 4 square root of 27 equals to negative 2 square root of 3. So in this third example, we have 6 square root of 32 minus 7 square root of 12. Alright, so taking a look at the square root of 32, looking at my perfect square, I'm not going to use 36, that's too high. 25 doesn't go into it. 16 does, and 4 does. So between 4 and 16, I'm going to use the higher perfect square. So I'm going to use 16. So step 1 is going to break the square root of 32. So 6, then 16 times 2 inside the square root. Bring down the minus. Now the 7, I'm bringing down. For the 12, 16 is too high. I'm not going to use it. 9 doesn't go into it, but 4 does. So I'm going to use 4. So 4 times 3 inside the square root. Next, I'm going to break into two radicals, two square roots. So bring down to 6. Write square root of 16. Then times the square root of 2. Bring down the minus. Bring down to 7. separating these into two separate square roots. So square root of 4 times square root of 3. So I separate it into two radicals, two square roots on each side. Then the one I underline is the one that we can apply the square root. So bringing down the 6 again, applying the square root on 16, which is 4. Can't simplify the square root of 2, can't break it down any further, so I'm bringing it down. Bringing down the minus, bringing down the 7 again. Here I'm applying the square root on 4, which is 2. And then here, can't simplify any further, can't break it down any further, so I'm just going to bring down the square root of 3. Now I'm just going to combine them. So 6 times 4 times square root of 2 is 24 square root of 2. Bring down the minus. Then I combine these three together. So 7 times 2 times square root of 3 is 14 square root of 3. Alright, let's check if we can combine these like terms. The 24 has square root of 2 and the 14 has the square root of 3. They're not the same, so therefore I can't combine them since they're not like terms. So what we can only do is just leave it like that. This is our final answer. So again, when it's coming to simplifying radicals, write in simple terms. So the only thing that we did here was just write in simple terms. Here, add, subtract terms if possible. Well, it was not possible to combine them by adding or subtracting. It is just like if I were to ask you, can you combine 3x plus 4y? Well, you cannot because they both have different terms. So when you have something like that, you can't mess with it. Just leave it like that. So 6 square root of 32 minus 7 square root of 12 will equal to 24 square root of 2 minus 14 square root of 3. Again, could not combine them because the radicals are different.